This is the second in the Factoring Trinomials video series, so if you haven't watched the first one, you probably want to go back and check that out. Today we're going to look at factoring trinomials where a is not equal to 1, and the method I'm going to show you to do this is grouping. This is not the only method for factoring trinomials. There are many methods, and you may find whichever one works best for you. Grouping is the one that is sort of foolproof, and so that's why I'm going to show it to you guys here. It also will come in handy when you start looking at other polynomials that are not just quadratics that have an x squared in them. Now, what I mean by grouping is we're going to be looking at two terms at a time and treating them like GCF problems. So if I had x squared minus 3x, I would be factoring this by finding the GCF. What do they have in common? The GCF of these is x, so when we factor that out, we have x minus 3. Another example of a small grouping that I would look at is like, say, 2x cubed minus 4x squared. We look at just those two things. The greatest common factor, the greatest number they both have is 2, and the greatest amount of x's they both have is 2, so 2x squared is the GCF. Divide that out, and we're going to be left with x minus 2. We're going to use looking at these smaller groups to help us do factor by grouping. So here we have a large polynomial. It's got 4 terms in it, although I see I could do some combining. Right now it's spread out into 4 terms, so let's deal with it in this form. I'm going to split it into 2 groups. I'm going to look at each group separately. So looking at the group at the left-hand side, I want to think about the GCF of these 2 groups, or these 2 things in the group. Looks like they both have a 3 in common. They also both have an x in common. So when I factor that out, I'm going to be left with x plus 2. Alright, did the first on the left. Now let's look at the ones on the right. Negative 4x and negative 8. Remember from factor by with the GCF, we always want to pull out the negative if it starts with a negative. So I'm going to pull out negative 4, and that's it. That's all they have in common. So when we divide everything by negative 4, we're going to be left with positive x and positive 2. So, ooh, how convenient. Look, we have a factor that's exactly the same. We have a factor of x plus 2. So I'm going to write that down. That's the same. And my other factor is what's left over, 3x minus 4. So this is factor by grouping. We're done. We got factor form. Our factor form is x plus 2 times 3x minus 4. You could also write it the other way if you wanted, as 3x minus 4 times x plus 2. How do I know if I did this right? Well, you can go back using double distribution. 3x times x is 3x squared. 3x times 2 is 6x. Negative 4x. And negative 8. Haha, we did it. Here's another one to group. Let's just go ahead and group the first couple together, and we'll group the second couple together. X squared and 6x. The GCF is x. Factor that out, and we're left with x plus 6. Negative 2x and negative 12. The GCF is negative 2. Factor that out, and you're left with x plus 6. So what's the same? X plus 6. What's left over? X minus 2. And we have our factored form. Factored by grouping. Oops, minus 2. My bad. Again, if you wanted to check this, you could use double distribution and go backwards. See if you arrive at the same thing. X squared minus 2x plus 6x minus 12. Yep, it's okay that those two are switched around because their signs are still the same. So these weren't too bad because they were already set up in things that I could group. Now we're going to look at some where we might have to do an extra step in order to get to this grouping place. So we're back at a trinomial. This is 2x squared plus 13x plus 15. Well, we want this to be like one of those grouping problems. Those are really easy. We just looked for GCFs. However, we only have 3 things, so we can't make any groups. We would leave somebody out. So we're going to make it into something with 4 terms. we're going to do that by splitting the middle term up. We're going to have 2x squared plus something times x plus another something times x plus 15. Once we have 4 terms, we're going to be able to use factor by grouping. How are we going to figure out what those 2 terms are? Automatically, we know that those 2 terms need to add to be 13, because that's what I split in half. And they need to multiply, here's the trick, they need to multiply to be 2 times 15, which is 30. Now, numbers that multiply to be 30 and add to be 13. 6 and 5. No. 10 and 3. Yes. Here's what's kind of cool about factor by grouping. It doesn't matter where you put the 10 and where you put the 3, you're still going to get the same answer. So I said 10 and 3, that's the order I'm going to write them down in. If you thought 3 then 10, you can do yours in that order. You're going to get the exact same thing I do. Now that we have 4 things, we can split it into groups. 2x squared and 10x. GCF is 2 and x. So we factor that out, and we're left with x plus 5. Now we start with a positive 3, so we don't have to worry about negatives on this one. 3x and 15. The GCF is 3, positive 3. When we factor that out, we're left with x plus 5. So to write our final answer, you think, what's the same? X plus 5. What's left over? 2x plus 3. We can always use double distribution to go back and see if we're correct. And again, you can leave your answer like this, or you can rewrite it as 2x plus 3 times x plus 5. I'll admit I kind of like having the term with the coefficient, like that 2x, in front, but it doesn't really matter. If you use double distribution, you're going to work out to get the same trinomial in the end. So we needed to make extra terms so that we could use grouping. Let's look at another example of that. 3x squared minus 14x plus 15. Right now, it's not ready to group. Somebody would be left out. So we need to make an extra term. We're going to have 3x squared plus something times x plus something times x plus 15. Now we need to make our little multiplication adding table. We need these numbers to multiply to be the product of these, which is 45. And we need our numbers to add together to be negative 14. Think about the other factoring video. We're multiplying to be a positive number and adding to be a negative number. That means that they both need to be negative. So let's think about numbers that multiply to be 45. 15 and 3. Haha, I just did that, right? Make them both negative. Ooh, not negative 14. So other numbers that multiply to be 45. 5 and 9. Right now they add up to positive 14, but if I make them both negative, they still multiply to be positive 45, but add up to be negative 14. So those are my 2 numbers. I'm going to fill them in the blank. It doesn't matter what order you put them in, you're still going to get the exact same answer. Then I'm going to group 3x squared and negative 5x. The only thing they have in common is an x. When we factor that out, we're going to be left with 3x minus 5. Negative 9x and positive 15. Remember, we have to take out a negative something. Number that they have in common is 3. So we're going to divide out that negative 3. Negative 9 divided by negative 3, we're going to get a positive 3x minus 5. Then, to write our final answer, we think, okay, what's the same? 3x minus 5. That was the same. What's left over? X minus 3. And we are done. If we wanted to be really awesome, we would use double distribution to go back and check. In fact, let's do that on this one. I'm feeling awesome. 3x squared minus 9x minus 5x plus 15. Combine those like terms in the middle and you get 3x squared minus 14x plus 15. That's what we started with, so that means we did it correctly. 3x minus 5 times x minus 3 is the factored form of this expression. 9x squared minus 3x minus 2. We are going to use grouping to do this. We cannot use grouping yet, so let's go ahead and let's split it up. We need a crowd of 4 in order to do some grouping. Split up our middle term, and then let's get our table ready to go. We need our numbers to multiply to be negative 18, and they need to add to be negative 3. So numbers that multiply to be negative 18, 9 and 2. No matter which way I put the negative, I'm not going to get 3. Other numbers that multiply to be 18. 6 and 3. So let's say we use positive 6 and negative 3. Is that going to add to be negative 3? Nope. But it adds to be positive 3, so that tells us that I just need to switch the signs. Negative 6 and positive 3 will work out to get us a negative 3. We're going to put those in our blanks, and it doesn't matter which blank you put in which. Now we can group. We got our pairs here going on. Let's find a GCF of each pair. 9x squared and negative 6x. GCF is going to be 3 and an x. Divide everything by that, and you're left with 3x minus 2. Now I have a 3 and a negative 2. They don't have anything in common. You have to factor something out, though. So the biggest number that they both have in common is 1. That's it. So I'm going to factor out a 1. Boring. You're left with 3x minus 2. Which, yes, was boring, but very convenient because look, what do we have the same? 3x minus 2. And what's left over? 3x plus 1. So now we have the factored form of the original expression. This is the last example we're going to do. Really, I'm just going to be doing the same thing over and over and over again. I have a big sheet full of examples, but this is going to be it. Remember, when you use factor by grouping, you have to have at least 4 terms. So if you only have a trinomial, you need to split one of the terms up. We're going to split the middle term up. So we get 4x squared plus something times x plus something times x plus 15. Now we need to find out what those blanks are, what those somethings are. And those somethings we know are going to add to be 23 because that's what I'm splitting up. And they're going to multiply to be the product of the other 2 numbers in the problem. 4 times 15, which is 60. So we're looking for numbers that multiply to be 60 and add to be 23. I know it already. Do you know it? 20 times 3. Awesome. Now, it doesn't matter which order you write those in your blanks. We just need to fill in the blanks. No, either way, you're going to arrive at the same solution at the end. So now we have enough things to group. We can make 2 pairs. It's like a double date. And let's look at the first pair. What do they have in common? They both like long walks on the beach. No, sorry. It's not double dating. We are grouping. So 4x squared plus 20x. 4. Yeah, that's the greatest common number, but they also have an x in common. So when we divide that out, we're going to be left with x plus 5. Now we look at the other 2. 3x and 15. There's a 3 I can factor out of that, and we're left with x plus 5. Then to get to our final answer, we think, okay, what's the same? What's left over? Alright, so there you go. X plus 5 times 4x plus 3. Those are your 2 factors for this problem. And then, of course, if you're like me and it bugs you to have things all out of order, you can rewrite it as 4x plus 3 times x plus 5. It really doesn't matter. It's the exact same thing, and when you check it, because you will check it, and you use double distribution to do that, you'll arrive at the exact same answer. So factor by grouping is a way for us to factor trinomials that have a values that are not equal to 1. So in this case, a was equal to 4. You can actually use it for a values equal to 1 as well, but sometimes it's a little more time consuming than using the method in the factoring video number 1.